Hello and welcome back to the Deep Dive. Today is December 14th, 2025, and if you have been following the trajectory of interstellar object 3I Atlas, you know that we are no longer looking at a standard celestial event. We are looking at a mystery that is deepening by the hour. Over the last 24 hours, a flood of new data has come in from independent observatories and major astronomical networks alike. And what we are seeing is frankly baffling. We are not just talking about a comet getting brighter or dimming as it moves away from the sun. We are talking about a fundamental shift in morphology that defies our standard models of cometary evaporation. The object is changing shape. It is pulsing with activity, and the latest images from December 13th and 14 reveal a structure that looks less like a dirty snowball and more like something alive with energy. Before we unravel this spider web of data, if you want to stay ahead of these rapid developments, because this story is changing literally overnight, make sure you are subscribed to the channel. We are tracking this in real time, and you do not want to miss the analysis of the Hubble data coming in the next few days. Let's look closer at the data. The headline today is the spider anomaly. When we look at comets, we typically expect a coma, that fuzzy envelope of gas and dust, and a tail, usually streaming away from the sun, driven by solar wind and radiation pressure. It is a passive process. The sun heats the ice sublimates, and the dust gets pushed back. Simple, predictable. But 3I Atlas is refusing to play by these rules. The freshest images processed late last night show a tail structure that has fragmented into what astronomers are calling a spider-like morphology. Instead of a single, sweeping fan of dust, we are seeing short, narrow jets diverging in multiple directions. It looks like the legs of a spider extending from the central nucleus. This contradicts what we previously thought about the stability of this object. We assumed that as it moved past perihelion, the outgassing would stabilize into a steady stream. Instead, we are seeing chaotic, episodic outbursts. These jets are not static. They are not like a faucet that has been left running. They are flashing. They appear suddenly, shoot out material with immense velocity, change direction, weaken, and then disappear, only to reappear in a different sector of the coma. This is high-frequency temporal variability. It suggests that the surface of the nucleus is not sublimating evenly. It implies that there are specific active regions, vents, if you will, that are triggering explosively and then shutting down. Imagine a pressure cooker where the valve doesn't just hiss steadily, but pops open violently at random intervals, spinning the pot as it does so. That is the kind of dynamic instability we are witnessing. The jets are even being observed directed toward the sun, which is highly atypical for a standard dust or ion tail. Solar radiation pressure should be overwhelming these emissions, pushing them back. The fact that these jets can punch upstream against the solar wind suggests they are being ejected with significant force. This isn't just evaporation. This is propulsion. The coma itself is demonstrating a behavior that is equally puzzling. We are seeing what looks like cyclone-like turbulent motion. The gas and dust envelope isn't just expanding outward in a sphere, it is swirling. This could be caused by the rapid rotation of the nucleus, which we will discuss in detail later, or it could be evidence of uneven heating creating massive thermal differentials on the surface. But there is another possibility: structural stresses. If the nucleus is not a solid block of ice, but a loose agglomeration of rock and exotic ices, or perhaps something with a rigid crust and a volatile interior, these stresses could be causing the surface to fracture, releasing these spider legs of gas in violent bursts. The activity assessment as of December 14th is off the charts. We are seeing a gas component that is incredibly high relative to the dust, but the composition is where it gets strange. We are detecting elevated nickel content compared to iron. In the solar system, comets usually have a specific ratio of these metals. 3I Atlas is breaking that ratio. Why is there so much nickel? Is it exposed on the surface? Is it being dredged up from the core? Or is the entire object made of something different than the primordial soup of our own solar system? The morphological stability is currently rated as low. That is scientific politeness for this thing is falling apart or transforming right in front of us. The shape you see in an image taken at 2:11 might be completely different from the shape in an image taken at 4:09 a.m. This high temporal variability is the smoking gun that tells us this is not a passive rock. It is an active, dynamic engine. The spider shape is likely a transient phase, a snapshot of a chaotic process where the object is shedding mass in a non-uniform way. So, what does this actually mean? It means we cannot predict what it will look like tomorrow. If these outbursts continue, the spider could evolve into a ring, a spiral, or a fragment completely. But there is one feature that has persisted, one feature that is even stranger than the flashing jets. As we move our attention from the chaotic coma to the tail structure, we find something that shouldn't be there at all. A structure that seems to defy the geometry of the encounter. As we established, the jets are firing in all directions, creating this spider effect. But amidst this chaos, a distinct organized structure has emerged that is drawing the attention of heavyweights like Avi Loeb. It is the anti-tail. And unlike the flickering jets, this feature is behaving with a disturbing kind of persistence. It is not just a trick of perspective. It is a physical structure, a swarm that is pointing in a direction that makes astronomers very uncomfortable. Building on this, we have to ask, if the jets are the engine, what is the anti-tail? Is it the exhaust, or is it something else entirely? The data from December 14th gives us a clue, and it involves a flip that has just occurred. The object has passed perihelion, and usually the geometry of the tail changes in a predictable way. But the anti-tail of 3I Atlas has rotated. It has flipped its orientation relative to the Sun, maintaining a coherence that suggests it is made of heavy, massive particles that are not easily pushed around by sunlight. This connects to the next phase of our investigation. We have the spider jets indicating a volatile, explosive surface, but trailing behind, or perhaps leading ahead, is this dense, mysterious swarm. It is a duality that defines 3I Atlas, the chaotic, gaseous explosion of the coma, and the heavy, silent persistence of the anti-tail. To understand what this object is, we have to understand what it is leaving behind. And the latest report describes this anti-tail not as a stream of dust, but as a swarm of unknown objects. Let that sink in, a swarm. We are going to dissect exactly what that means and why this swarm might be headed in our direction in the next part of our deep dive. The spider is just the beginning. The web it is weaving is far more complex. Welcome back. In the previous segment, We analyzed the chaotic, spider-like jets that are erupting from the nucleus of 3I Atlas, painting a picture of a volatile, explosive object. But as we shift our focus from the immediate vicinity of the nucleus to the broader structure of the comet, we encounter a phenomenon that is perhaps even more unsettling. It is the feature that has kept Avi Loeb and independent astronomers awake for the last few nights: the anti-tail. Here is the crucial detail. Usually, an anti-tail is an optical illusion. It happens when Earth crosses the orbital plane of a comet, and we see the dust trail edge on, making a spike that appears to point toward the Sun. It is a geometry trick, but for 3I Atlas, the geometry doesn't quite add up to a simple illusion anymore. The latest data from December 14th describes this feature not as a passive trail of dust, but as a swarm of unknown objects arranged in a droplet shape. And most critically, this structure has flipped. Avi Loeb has emphasized this point repeatedly in his recent reports. After perihelion, the point of closest approach to the Sun, the anti-tail didn't behave like a standard dust trail. It rotated. It maintained its integrity. It flipped its orientation in a way that suggests it is not reacting to solar radiation pressure the way typical cometary dust does. If this were fine dust, the solar wind would have blown it back, dispersing it into a diffuse fan. But it hasn't dispersed. It has remained tight, coherent, and highly reflective. This insensitivity to solar radiation is a massive red flag. It implies that the particles making up this anti-tail are large. They are heavy. They are too massive for the pressure of sunlight to push them around. We are not talking about micron-sized grains of soot here. We are potentially talking about pebbles, boulders, or chunks of refractory material, rocky fragments that can withstand intense heat without vaporizing. The description of a swarm is deliberate. It suggests a collection of discrete bodies moving in formation rather than a continuous fluid of gas and dust. Let's look closer at the data regarding its position. As of today, December 14th, the comet is approximately 270 million kilometers from Earth. It is moving at a blistering speed of 63.7 kilometers per second, and it is accelerating. The anti-tail, this swarm, persists after perihelion, and, due to the orbital geometry, it may be directed toward Earth by December 19th. Now, do not panic. This does not mean a collision is imminent. The distances are vast, but it does mean that we are going to get a front-row view of this structure. We are going to be looking right down the barrel of this swarm. This alignment provides a unique scientific opportunity, but it also deepens the mystery. If the anti-tail is made of heavy, rocky fragments, where did they come from? A typical comet is mostly ice. If 3I Atlas is shedding massive amounts of rock, it suggests the internal structure is differentiated. It might have a rocky core that is breaking apart, or a crust that is shedding tiles. The high reflectivity of this swarm is also puzzling. Dark, carbon-rich asteroids are not very reflective. Ice is reflective, but ice should have sublimated or been blown away. So we have a swarm of heavy objects that are also shiny. What material fits that profile? Refractory dust? Metallic fragments? This brings us back to the droplet shape mentioned in the new reports. A droplet implies surface tension or a cohesive force, or perhaps an aerodynamic shaping by the solar wind. But if the material is insensitive to solar wind, Why the droplet shape? It suggests that the ejection mechanism, the force that threw these objects out, was directional. It wasn't a spherical explosion. It was a directed release. I want to pause here and ask you a question. If you were looking at an object that had a chaotic, explosive engine at the front, the spider jets, and a heavy, coherent, non-reactive structure trailing behind it, the anti-tail, would you still call it a comet? Or would you start looking for other definitions? Let me know in the comments what you think this swarm actually is. Is it debris? Or is it something else? So, what does this actually mean for the flip? The flip indicates that the orientation of this swarm is tied to the orbital dynamics of the main body in a rigid way. It is moving like a rigid extension of the nucleus, rather than a loose trail of smoke. This adds to the multitude of anomalies noted by Loeb. He points out that if this were a natural process, we should see a smooth transition. Instead, we see sharp changes. The flip is a discontinuity. It is a sudden change in the visual presentation of the object that correlates with its passage through the intense gravity of the Sun. The anti-tail is currently the strongest evidence we have that 3I Atlas is not a fluffy snowball. It is a solid, dense object capable of shedding large debris fields that maintain their cohesion over millions of kilometers. And as we approach December 19th, the angle of observation is going to become perfect for analyzing the density of this swarm. But the anomalies don't stop at the physical structure. If the spider is the engine and the swarm is the wake, then we need to look at the fuel. We need to look at the energy signature this object is giving off. And that brings us to the invisible spectrum. The latest observations have picked up something that is incredibly rare for comets: X-ray emissions. As we established, the physical behavior is bizarre, but the chemical and energetic behavior is about to throw another wrench in the works. We are seeing high-energy interactions that shouldn't be happening. We are seeing color changes that indicate a shift in chemical composition. The object is changing its skin as it travels. Building on this, the next piece of the puzzle lies in the light spectrum. The comet has turned green, but not just any green. It is a specific signature of diatomic carbon that tells us something profound about the gases being vented. And when you combine that with the X-rays, you get a picture of an object that is interacting with the solar environment in a way that is almost aggressive. This connects to the idea of the chemical engine. If the spider jets are the exhaust, what is the reaction driving them? Why is there so much nickel? Why are we seeing X-rays? In the next chapter, we are going to dive into the spectral analysis. We are going to look at the blood of the comet, and we are going to find that it is running hot. We have covered the spider jets and the swarm anti-tail. We have established that physically, 3I Atlas is behaving like a rigid, volatile object shedding heavy debris. But to truly understand what is happening inside that nucleus, we have to look at the light it emits. We have to look at the chemistry. And the latest spectral data from December 14th reveals a chemical engine that is running on a very strange fuel mixture. Let's look closer at the data regarding the X-ray emissions. This is a headline in itself. Comets are cold. They are icy bodies. They do not typically emit X-rays on their own. When we see X-rays from a comet, it is usually the result of a process called charge exchange. This happens when highly charged ions in the solar wind, particles streaming from the sun, slam into the neutral gas atoms in the comet's coma. They steal electrons, and in the process, they emit an X-ray photon. The fact that we are seeing a strong X-ray signal from 3I Atlas confirms that the gas envelope is incredibly dense and active. It is not a wisp of gas, it is a thick shield. The interaction is violent. The solar wind is hammering the comet, and the comet is fighting back with a massive outpouring of gas. This enhances the assessment of high gas activity we noted earlier. But it is the intensity of this emission that is catching eyes. It suggests a volume of gas production that rivals much larger comets, despite the relatively small size of the nucleus. But the visible spectrum is where the story gets colorful, literally. New images show a distinct greenish tint to the coma. This is caused by C2 molecules, diatomic carbon. Now, green comets are not unheard of, but the timing and the shift are what matter here. Before perihelion, the object had a reddish hue. Red usually indicates tholins, complex organic compounds irradiated by cosmic rays over billions of years. It is the color of the outer solar system. It is the color of age. So, what does this actually mean? It means the comet has shed its old skin. The heat of the sun has vaporized that outer red crust, and now we are seeing the fresh, volatile material from the interior. The shift from red to green is a sign of unmasking. We are seeing the heart of the comet exposed, and this green glow is intensifying in the anti-tail region, which is fascinating. Usually, the tail is dust, yellow-white, or ions, blue. To see the C2 signature intensifying in the anti-tail suggests that the swarm we discussed is not just dry rock, it is outgassing. The fragments in the swarm are themselves releasing gas. This contradicts what we previously thought about the anti-tail being just heavy debris. If it is glowing green, it means the debris is volatile. It means the swarm is active. And then there is the composition. The spectral analysis is picking up signatures that are raising eyebrows. We are seeing indications of methanol, CH3OH, hydrogen cyanide, HCN, carbon dioxide, CO2, and, most puzzling of all, elevated nickel. We mentioned the nickel earlier, but let's drill down into why this is weird. In our solar system, iron and nickel usually come together. They are the heavy metal brothers. To see a high nickel-to-iron ratio is chemically odd. It implies a formation history that is different from the standard accretion disk model of our solar system. It suggests that 3I Atlas was born in a place where the chemical cookbook was different. Maybe a region rich in siderophile elements, or a system where differentiation processes separated the iron from the nickel in a way we don't see here. The presence of methanol and HCN is also significant. These are prebiotic molecules. They are the building blocks of life. But in the context of the chemical engine, they represent volatiles that sublimate at different temperatures. The fact that we are seeing them all at once, mixed with the high-temperature release of metals, suggests a chaotic internal structure. It is not a neat layer cake of ices. It is a marble cake, a jumbled mix of deep-freeze volatiles and heavy metals. This unusual composition might explain the spider jets, If you have pockets of highly volatile HCN trapped inside a matrix of rock and nickel, when the heat hits those pockets, they don't just melt, they explode. They create the pressure bombs that drive the episodic outbursts. The chemical engine is unstable because the fuel is mixed poorly. It is a dirty engine, sputtering and backfiring as it burns. Building on this, the asymmetry we observed in the coma, the cyclone motion, makes more sense when you consider this chemical chaos. If one side of the comet is rich in CO2 and the other is rich in methanol, they will sublimate at different rates. This creates uneven thrust. The comet isn't just melting, it is being pushed around by its own exhaust. This connects to the next major anomaly, the movement. We have a chemically complex object, firing jets randomly, shedding a swarm of active debris, and glowing with X-rays. All of these forces, the jets, the outgassing, the solar-wind interaction, impart force to the nucleus. They push it. And this brings us to the asymmetric drive. The orbital parameters are shifting. The math isn't lining up. The astronomers are calculating where the comet should be based on gravity, and the comet is seemingly deciding to be somewhere else. These are called non-Gaussian accelerations, and for 3I Atlas, they are off the charts. In the next chapter, we are going to look at the physics of this movement. We are going to talk about A1, A2, and A3, the parameters that measure how much this object is deviating from a gravity-only trajectory. And we are going to find that the chemical engine is driving the comet in a way that looks suspiciously like organized asymmetry. We have analyzed the spider jets, the swarm anti-tail, and the chemical engine fueling this activity. Now, we must look at the consequence of all this chaos, the movement. If 3I Atlas were a simple rock, its path would be determined solely by the gravity of the Sun and the planets. It would follow a Keplerian orbit, predictable to the meter. But 3I Atlas is not following the script. It is exhibiting what astronomers call non-Gaussian accelerations, NGA, and the latest data from December 14th shows that these accelerations are significantly exceeding the norms. Let's look closer at the data regarding the parameters A1, A2, and A3. These are the variables scientists use to quantify non-gravitational forces. A1 is the radial force, away from the Sun. A2 is the transverse force, along the orbit. And A3 is the normal force, perpendicular to the orbit. For a typical comet, A1 is the dominant term. It represents the rocket effect of outgassing, pushing the comet away from the Sun. But for 3I Atlas, the updates show anomalous values across the board. The A2 and A3 components are unusually strong. This contradicts what we previously thought about the nucleus's rotation. Usually, if a comet has strong non-gravitational acceleration, it is because it is rotating rapidly, spraying jets like a garden sprinkler. This rotation averages out the forces, or creates a consistent drift. But here is the mystery. The nucleus rotation does not cause the expected blurring of the tail structures. The spider jets remain distinct. The swarm remains coherent. If the nucleus were spinning wildly enough to generate these massive NGAs, the centrifugal force should be tearing the coma apart into a uniform haze. Instead, we see organized asymmetry. Fresh data from December 14th reveals an asymmetrical coma that is visually striking. The luminous nucleus is compressed and offset from the center of the gas envelope. Imagine a light bulb inside a balloon, but the bulb is pushed against the side wall. That is what we are seeing. The envelope is shifted. It does not expand evenly. This confirms that the outgassing is not global. It is highly localized. The jets are firing from specific, perhaps fixed, locations on the surface that are not aligning with the solar direction. This shifted envelope is a physical manifestation of the asymmetric drive. The comet is pushing itself sideways. The brightness changes frame by frame, which we mentioned earlier, are not just random flickers. They are pulses of thrust. Every time the brightness spikes, it means a fresh ejection of mass, and every ejection of mass carries momentum. The comet is essentially a natural rocket with a stuck throttle and a wobbly nozzle. So, what does this actually mean for the trajectory? Avi Loeb has pointed out that the trajectory has a low chance of being random. When you combine the flip of the anti-tail, the specific direction of the jets, some pointing toward the sun, and the high A2, A3 parameters, you get a motion vector that is complex. It is not just tumbling, it is maneuvering, not in the sense of intelligent control necessarily, but in the sense of a complex aerodynamic and hydrodynamic interaction with the solar wind. The organized asymmetry is the key phrase here. Random noise looks like static. This looks like structure. The jets do not align with the solar vector. Usually, jets point toward the sun, where the heat is. Here, they diverge. This implies that the internal heat distribution of the nucleus is lagging, or that the vents are geologically constrained to point in specific directions regardless of where the sun is. This could be due to the structural stresses we hypothesized in Chapter 1. If the comet is cracking, the cracks dictate where the gas goes, not the sun. This connects to the rotation issue. The fact that the rotation doesn't blur the tail suggests the rotation might be slow, or the axis is highly stable despite the torque from the jets. This is a paradox. High thrust usually means high torque, which leads to spin-up and eventual disruption, breaking apart. 3I Atlas is accelerating, pulsing, and jetting, yet it maintains a strange kind of stability in its instability. It hasn't disintegrated yet. It is holding together under forces that should have crushed a rubble pile comet. This resilience suggests the nucleus has internal strength. It is not just a loose ball of dust. It might be monolithic, a single solid rock with volatile pockets. This fits with the swarm theory. If the outer layers are shedding, the core remains. As we look at the orbital updates, we have to consider the cosmic verdict. We have a list of anomalies that is getting longer by the day. Spider jets, swarm anti-tail, X-ray emissions, green C2 shift, high nickel, offset nucleus, non-Gaussian acceleration. Is this just a weird comet, a statistical outlier, or is it, as some have dared to whisper, something else? The line between natural anomaly and artificial signature is defined by Occam's razor. The simplest explanation is usually the best, but at what point does the simple explanation require so many caveats and exceptions that it stops being simple? Building on this, the final chapter of our deep dive will tackle the elephant in the room, the debate that is raging in the scientific community. NASA says it is natural. Loeb says we are ignoring the data. The verdict is not yet in, but the evidence is mounting. And with Hubble and X-RISM, about to take a look. We are on the verge of an answer. In the next file, we wrap this up. We look at the implications, we look at the future, and we ask the ultimate question: what is 3I Atlas? We have arrived at the final chapter of our investigation. We have dissected the anatomy of 3I Atlas from its spider jets and swarm antitail to its chemical engine and asymmetric drive. The data is undeniable. This object is an anomaly among anomalies, but data without interpretation is just noise. Now, we must synthesize these findings and face the question that is dividing the scientific community. What are we actually looking at? On one side, we have the mainstream consensus, represented by agencies like NASA. Their stance is clear and grounding. 3I Atlas is a natural object. It is a new type of comet, perhaps, or a fragment from a destroyed planetesimal, but it is a product of natural cosmic evolution. They emphasize that the anomalies, the X-rays, the nickel, the jets, can be explained by extreme physics. The spider shape is just irregular erosion. The swarm is just a disruption event where the comet shed a layer of crust. The X-rays are just a high-density solar wind interaction. To them, the mystery is a puzzle to be solved within the laws of known planetary science. They assure us it poses no threat and will be visible until September 2026, giving us plenty of time to study it. On the other side, we have the provocateurs, led most visibly by Avi Loeb. Their argument is that we are fitting square pegs into round holes. Loeb criticizes the scientific community for ignoring anomalies or dismissing them as weird natural events without sufficient proof. He points to the flip of the anti-tail, the insensitivity to solar radiation, and the non-random trajectory as potential signatures of artificiality, or at least of an origin that defies our current understanding of natural formation. He asks, why does the anti-tail look like a swarm of unknown objects? Why is the acceleration so organized? Why is the object so resilient? Here is the crucial detail. Speculation is not science, but hypothesis is. The artificial origin hypothesis is not about little green men. It is about technology. Could this be a defunct probe, a piece of space debris from another civilization? Or, more conservatively, is it a dark comet or an interstellar shard composed of material we have never seen before, like hydrogen ice or a nitrogen alloy? The discussions from December 14th reflect this tension. Experts are scrambling to find natural models that fit the data. They are proposing sterile neutrinos or exotic dark matter interactions to explain the mass discrepancies. These are fringe theories entering the mainstream conversation because the standard theories are failing. When you have to invoke sterile neutrinos to explain a comet's orbit, you know you are in uncharted territory. So, what does this actually mean for us? It means we are watching a paradigm shift in real time. Whether 3I Atlas is a natural exotic rock or an interstellar artifact, it is teaching us that our catalog of the universe is incomplete. The coming days are critical. We are waiting for the cosmic verdict from the heavy hitters. The Hubble Space Telescope is scheduled to image the comet, providing resolution that ground-based telescopes cannot match. We will see if the spider is truly jets or something else. We will see the individual components of the swarm. The XRISM satellite, X-ray imaging, and spectroscopy mission We'll analyze the X-ray spectrum in high fidelity, telling us exactly what elements are being ionized. If Hubble shows a swarm of metallic debris, the artificial debate will explode. If it shows a crumbling ball of ice, the natural camp will claim victory. But until those images come down, we are in the twilight zone of discovery. As we established, the comet is accelerating. It is moving away. We have a limited window to solve this. By September 2026, it will be a ghost in the darkness. But right now, on December 14th, 2025, it is the most interesting object in the sky. My verdict: 3I Atlas is a messenger. It is telling us that the interstellar medium is full of surprises. It is telling us that comet is a label that might be too small for the reality of what is out there. It is a spider, a swarm, a chemical engine, and a mystery, all wrapped in one. We will be here to cover the Hubble data the moment it drops. We will be here to analyze the X-RISM reports. This story is far from over. If you enjoyed this deep dive into the unknown, please hit that like button. It helps the algorithm find other curious minds who want to look up and wonder. And don't forget to check the description for links to the raw data and the papers we discussed today. Keep watching the skies. The universe is speaking. We just need to learn how to listen.